The Woodman Point wastewater treatment plant was built in 1966 in the suburb of Munster, 8 kilometres south of Fremantle. At the time, the area was sparsely populated, home to scattered market gardens, marine industry and a few residential properties. It was designed to service a population of just 50,000 people living south of Perth. Today, 42 years on, the plant is treating wastewater from a population of 600,000 people, a figure that is set to double by 2045. Given the flat, spread-out geography of the catchment area, wastewater treatment in Western Australia is a tough business. In summer, the journey through hot pipes provides ideal conditions for the increased production of hydrogen sulphide, the main cause of odour produced from wastewater treatment plants. With increased demand for residential developments in the southern corridor, some very close to the plant itself, the challenge was on to upgrade the Woodman Point facility to handle double the demand with half the odour and manage the environmental and economic costs. To meet this challenge and deliver a 5-year, $350 million program of works to upgrade Perth's metropolitan wastewater treatment plants, the W2W Alliance of Black & Veatch, SKM, TEAS and the Water Corporation was formed in November 2006. The Alliance's innovative solution to the Woodman Point odour problem combines biological and chemical treatments, as well as improved odour capture and dispersal methods. Its success has made it a model for upgrades at other wastewater treatment plants, including Beanyup in the northern suburbs and Subiaco, situated close to Perth CBD. Combining the strengths of the Alliance partners and utilising a workforce of some 270 people, the project incorporated process, civil, structural and mechanical works, as well as associated piping, electrical and instrumentation installation. The Water Corporation was also very much part of the team, with involvement in the intensive consultation process in the design workshops to ensure the final asset not only met the objectives, but was easy to operate and maintain throughout the asset's 20-year life. Whilst researching possible design alternatives, key Water Corporation personnel visited a sister plant in the eastern states to view a bio-scrubber in action and were impressed with the operator's feedback on its simplicity and savings. And the team's expertise was bolstered by including the former Woodman Point plant manager and operations supervisor, adding extra depth with their specific knowledge of the plant, its operations and its history. So how did all this come together to deliver the desired outcomes? Odour is now captured more effectively at the various plant assets and drawn through a series of ducts to the odour removal facility, which treats the odour in 3 stages. The bulk of the odour is treated by the bio-scrubbers, with the chemical scrubbers acting as critical control points and providing a fully capable backup option in the unlikely event of a biological system failure. In the first stage, microorganisms contained in a series of bio-vessels consume more than 90% of the odour. The air is then passed through a series of chemical treatment vessels to remove any final odours. This provides any necessary polishing of the air to achieve a 99.9% odour removal before passing it through to the 50-metre stack for high-level dispersion. Traditional chemical odour treatment requires massive amounts of drinking water and large quantities of sodium hydroxide and sodium hypochlorite. As well as the benefits in odour reduction, the plant's bio-scrubbers use recycled wastewater, saving 900,000 litres of drinking water a day. That's almost 3 Olympic swimming pools every week. In addition, by managing over 90% of the odour treatment, the carbon offset in chemical savings equates to the equivalent of planting 3,000 trees a year, or 60,000 over the 20-year life of the asset. Now fully operational and undergoing rigorous performance testing, the project is exceeding expectations. In fact, The bioscrubbers have shown themselves fully capable in effectively managing every introduced odour source, with the chemical scrubbers providing backup capacity in the unlikely event of biological failure. This is an outstanding result that bodes well for the future. Compared to traditional chemical treatment methods, this innovative project will save the Western Australian community an estimated $1.4 million a year, and local residents can stop holding their breath for the delivery of a clean, environmentally sustainable solution to wastewater treatment.